Alright guys, welcome back to the another video. In this video I'm going to talk about random forest classification for satellite imagery. So in order to do so I'm going to use the water bodies satellite imagery dataset from Kaggle, which was prepared by me, and then I'm going to detect the water bodies such as river and lakes from the satellite imagery like this. So let's get it started. Alright guys, before diving into the coding section, so I want to let you know about a little bit about random forest classifier first. So the random forest is a popular machine learning algorithm that creates an ensemble of decision trees and combine those predictions to achieve better accuracy and avoid overfitting. The algorithm randomly select the subset of features and data points for each tree and use a majority vote to determine the final prediction. So in this example, so in this image, so you can see our job is to find whether this is red text or the blue text, and then it try to like pick the one value first, and then is it red, it will say if it's yes, then it will fall within these three 110 class, otherwise it fall in blue class. And again it will again apply some condition whether it's underlined or not, and then if it's yes, then the value will be 1 1, otherwise no. And in similar pattern, so random forest will assign the different decision tree and then try to predict based on the majority votes. And then in the below image, so here let's say we have four features, and then it will try to create the different node on different features. Let's say for the left node we have feature 2 and feature 3, which were randomly assigned, and then it also has left node and right node. Of course, maybe a left node will be based on feature 2 and right node may be based on feature 3. And then also let's say on the random forest tree second tree, so it will take only the two features, feature 1 and feature 3, and then there is also left node and right node, and based on those nodes, and then it try to calculate the majority vote and then define the determine the final prediction. So I think that's all about algorithm. But if you want to learn more about random forest, you will find lots of resources in the Google and internet, since it's the popular method. I'm not going to explain everything here, so you can search and easily find everything related to random forest in the internet. So the main job for this video is to like do something hands-on experience with random forest classifier in the geospatial data. So in order to like detect the water bodies from satellite imagery, so I have created the test set and train set data set over here in the Kaggle. So if you I'll don't worry, I'll provide you this link. So here you will find four files: xtest, xtrain, ytest, ytrain, and based on these files, so you can simply open this file using raster library. And this is my satellite imagery is contain four bands: red, green and blue, and also the NIR band. And then if you check the our predict like water bodies file, so it's just the marks file. This blue color represent the pixel with water, and then another color, purple color, represent the pixel without water. That means it does not contain any water. So yeah, this is the basic general form of our data set. So this region is Pokhara city, one of the popular city in Nepal. So I'm going to like train my model in this region, and then I'm going to test it in the other region from Nepal, somewhere from Nepal. Okay. So in order to do so, let me create the new Python file first. First of all, I want to import some packages. So first thing is import numpy is np, and then import pandas is pd. Those are the core packages, and then of course I need rest rio is rio, and also I need to plot something, so I'll import matplotlib.pyplot is plt, and then I think I'm ready to go. So I'll run this cell, shift enter, and after that I want to test my dataset. Okay, I already downloaded this dataset over here. So it's inside random forest slash data directory. I have these four files. Don't worry about the supplementary data.zip. You don't need this data. We are going to use only these four files. So first of all, I'll simply try to read the dataset. So rio.open, and then my dataset is inside maybe r, and then it's inside the data directory, and then the file name is extend.tif. And if I write des.meta, then it will write me the metadata of my dataset. And of course my dataset has width and height of this 3246 and 2147, and count means I have four bands, RGB and NIR band, and this is the coordinate system. And then don't worry about this transformation, we don't need it. And of course the data type is fluid 32. And in order to like get the array of those pixels, so I can write array equal to maybe array equal to ds dot read. And if I write array, then I'll get all the arrays listed in this file. So don't worry about these non values. I think those are the the boundary pixels. All value are none. We need to convert this non value to something, some numeric format, because our machine learning model cannot read the non value. So in order to convert these numbers, so I'm going to write some condition. So which is np.where if the value is none, then I'll override it with zero value. And then if it's not none, then I'll write array. And then if I write arr, now you will get all the zero values. And these three dot represent there are lots of other rows as well, and between which you will get the actual data set. And in order to make it comfortable with to work with the machine learning libraries, so I want to try the shape. So my shape is this is the number of rows, this is the number of column, and this is my number of bands. So I want to move my band axis to the last axis. So I'm going to move axis is array and then 0, and my 0 first axis I'm going to move it to the last axis. That means 4 will be replaced in the last axis. So if I say array dot shape, then my band, I mean the first axis converted to last axis. And now I want to reshape it. So maybe I'll write xtrain, and then I want to reshape this axis to the array dot shape 0, and then into array dot shape 1, and then array dot shape 2. What I mean is I'm simply multiplying this row and column values, and then creating the only the two-dimensional array of my training file, and then which contain the four different like bands it's similar to like stacking different like layers on top of each other. So if I do so, then my new shape will be the this one. So 6969162, and then it's of course 4 bands. So this is my final training file, and I have to do the same thing with other dataset as well. So okay, let me do it with the y-train which is the output file, and then maybe okay, maybe I need to change it to y-train, and then try to write y-train.shape. Okay, it's also the same, but it has only one band, which is the max band, whether the value containing 0 and 1. And maybe I also like can read the and rows to the and rows train to array, and then a number of rows, and call train is array and 1. And maybe I can also like close uh, this file. Okay, so number of rows, number of column, I already highlighted. Okay, now I can do the same thing for the test dataset as well. So I can write test test, and then also I need to write yak test, and of course I need to like print out x x test, print x test dot shape. Okay, now my test data has the different shape, so I can copy this file and then paste it here, and then maybe y test, and also here y test. Okay, yeah, one thing you might have noticed that we have like we need same kind of like same shape is x test. I mean the first index should be same as the um, same for x and y variable. That means for the training data set as well, we have the shape 6969162, and then also for this y shape we have also same number in the first axis. So yeah, so now we already generated the like we already reshape, and we already like clean our preprocess our input data set. Now the next step is to write the random forest classifier. So in order to work with random forest classifier, you can like import maybe from sklearn dot ensemble import random forest classifier. Okay, okay, random forest classifier, and after that you need to like write the algorithm here. So rfc equal to random forest classifier, and then you need to add the estimators. The default value is 100. I'm going to use the default value, and then this random forest specify it will use the same similar kind of tree structure, so that we'll get the similar kind of accuracy. And then verbose is for like while running your model, whether you want output or not. So I need all the like outputs so that I can see my model is training well. So I write 3. If you don't want, then write it at 0. And then and jobs to -1. That means it will use all the CPU, available CPU, to train my model. Okay, after that, I want to fit this model with the X train, my training dataset Y train. So it will, I think it will take some time, so it will build the 100 trees and then try to like estimate the best possible class for the uh, each pixel. So I think it will take some time, so I think for me it took around 10 minutes. So I'm going to pause the video here and then start again whenever it done. All right, so my model is trained successfully. So it took around 7 minutes 20 seconds for like finishing my job. So now it's like predicting time. So in order to like predict the model output, so you can like use the our model rfc dot predict function, uh, and then you need to pass your data set. So for me it's a yak test. So it will take also few seconds to run, and after that actually you can see the accuracy metrics. In order to check the accuracy metrics, so you can simply import classification report from Yaskellon. So classification report, and then try to print the classification report, or simply classification report and y test data and then y predict, and it will generate some kind of matrix. Okay, I think it's not good. Print classification report. Okay, now if you check the like our accuracy, so our precision is for the non-water bodies it's 0.88, and the f1 score is 0.94, which is pretty high, and then really our model is doing really well. But for the water bodies our precision is 0.82, which is I think it's good, but our f1 score is 0.12. That means it's not doing that much great in the test data set. So there might be like several ways you can improve this accuracy, but for today's video let's make it simple. Maybe in the upcoming video I'm going to like increase this accuracy by changing some of the parameter, or by some of the technique using Askelon Python library. So now I think our shape of the like prediction is y pred dot shape, uh, and it's like 4207593, which is like similar to 4207593 for the test data set. Of course we need to like reshape it, and then also we need to like reshape it in the row versus column versus band order, so that we can visualize our result. In order to do so we need to change the shape. So I have write some code somewhere, so maybe I can paste it here. So why predict reshape? First of all we need to reshape based on like array dot shape, maybe not the array uh, test, I forgot the name, yan rows test, yan call test. Okay, uh, and rows test, and then I need to convert it to row versus column, so that I'm writing this and call test. And then also for the y predict I need to like simply change it in this way. So okay, and for this one also like I need to change yan rows test and yan call test. And of course for the yes, test dataset we have 4 bands, so I'm writing 4. And for these two we have 1 band, so I'm just neglecting those two. And it's completely fine to like remove the last band if it did not contain the information. So only integer scale arrays can be converted to scalar index. Maybe I can check and row paste. Oh, it's dot shape. Okay, I think sorry, I forgot to like assign here array 0 means it's taking the actual value. So instead of that, I need to write array 0 dot shape, and no, array dot shape, and then I need to take the 0 value, and array dot shape I need to only take the actual actual number of rows and number of column, not the actual value. So I'm rerunning again so that my and row text and column will be different. So now if my number of rows and column in the y predict is 1677 and 2509, which is similar to my test received. Okay, so in order to like print these images, so I have write some code over here, so I'm simply going to paste it here and then maybe explain. Okay, we don't need this. Okay, here I'm using the matplotlib pyplot library to plot the figures. So I first try to create subplots with 1 rows 4 columns, and then I'm going to share the x and y axis, and then this is the figure size. Okay, in this way I'm simply assigning each axis, and then for the first RGB values, so my first number of rows, number of column will be all of the number of rows and column I need. And for the RGB I need only first 3 band, that's why I'm writing first 3. And for the NIR, it's the last band. Instead of you can write it as fourth band is 3, since the index begin from 0. Otherwise you can write -1 as well. And okay, so for the ground truth, you have same shape, so you don't need to assign any number of bands here. And then for the prediction also you don't need anything. Okay, if I rerun this, now you can see this is our actual satellite imagery, this is NIR band, and this is my ground truth value. Actually in my case I think it's the ground truth is not that accurate, because this river contain lots of like sediments or sands in the beach. So it's the ground truth is taking all the areas, so it's not that perfect ground truth. And but for the prediction, actually we can see the river shape of the river, right? So it's pretty like well represented. So I think it's a like great way to like predict and detect the water bodies, river and lake from the random forest classifier. All right, that's all about like detecting water bodies from satellite imagery. I hope you enjoyed this video. If you enjoy it, hit the like button and subscribe to my channel. Thank you for watching.